Good evening, guys. I hope you're doing well. My name is Dr. Nanette K. Hartley. I prefer to be called Nan. Feel perfectly fine saying that. Or professor or whatever, however you want to address me, that's perfectly fine. I am going to do a little introduction about myself and some of the D12 stuff. There'll be more detailed videos about some of this later on. This is just the intro part. Not all of what I'm going to show you right now will be visible to you yet. When you first come into this shell, all you'll be able to see is the announcements, some of the material and content, and that's the course documents, and I'll walk you through that. And then the first couple of homework things that you have to do, and we'll talk about that. So as far as me, I started college in 1991. I graduated from my BS from the University of California, Riverside in 1995. I then went to Iowa State for 2 years, not successfully. Then I went to Arizona State, and I started there in 1997, and then I finished there with master's and PhD in 2002. That was a fun and arduous task, but it did take me some time. But I did actually go through the graduation for master's and PhD. So I have all three of those degrees. I studied analytical chemistry, which is the study of how much of what is present. So I'm very particular about knowing the identity of things, knowing how much of them there are. And there are certain things that analytical chemists do that other chemists don't. I'm very particular about how precise an instrument is. We'll talk about what that means later, but significant digits, those are big things in my mind. So that's stuff that we'll be talking about. Okay. Other stuff. I have been teaching on and off since I finished my first course in 1981. I started tutoring other people as an undergraduate. I worked for the chemistry department, writing class notes and selling them for the department. I also worked in the audiovisual part of the department so that I could be present for all of the lectures that they did. I thought that was fun. I did research in the chemistry department as well. I was a very dedicated student. I know that is not what you guys may or may not be. You may or may not be a full-time student. You may have a full-time job to go with what you're doing. So the expectations are not that same level. Okay, so I do understand that you have things outside of this, lives that you live, and I'm not expecting you're going to be available during the day or that you'll be able to do things at any given time. So if you need to talk to me, let me know what your availability is, and I will be happy to make appointments with you whenever. I can be flexible about that. Outside of work, and there's not much outside of work, but outside of work, I do some volunteer work with an organization here in Somerville, and I have a family. My husband is a chemist as well. My child, who is now almost 16, is a student and working on things, getting ready to also go to Trinet Tech for a degree there. So she's considering cybersecurity is where she's at. There is a bio that I have, and I will show you where that is so that you can see that. And that means we'll start looking in the shell. So what I have here is the shell for the full summer course. I also have one for the fast forward course. These are slightly different, but I mean, they contain the same things, except the lecture schedule is very different. So, sorry. I mentioned that my bio was here. It's in the discussions. So this is a lot of the things that I just told you, same kinds of things that we have. So that's my intro. You will be introducing yourself to us, okay? When you do so, it's not in that one yet, sorry. I need to go in here. I haven't finished everything yet, and I keep forgetting where we are. So there are a few things that I want you to include in your intro discussion. Now, this is a graded activity. Your discussions will be graded, but I need to know your full name. If you have another name that you would prefer to be called, your major or area of interest, and why do you have to take this class? Now, I do not want to hear somebody said I had to. It's in my program. I want a little more thought than that. If you're going to be a nurse, why do you need to take chemistry? Why is it important that you take chemistry? If you're going to be a biologist, why do you have to take chemistry? Why is that necessary in the path that you're on? That's what I want you to be thinking about. And then I want to know your word. Okay. So what do I mean by word? You get one word to define yourself to the rest of us. That word choice is very informative to me in terms of who and what you are. So it's very helpful for me to see what you respond with that. There's one other thing I need to put in here, and that's, are you mathematical or are you not mathematical? So some people are more concept-based. They don't like the mathematics that go with things. Some people are mathematical people, and they just want the equations. It's useful to me to know which of those you are, so that when I start to talk to you on one-on-one, then I know which approach to take. I can do both of them. I happen to be a math preference, but I can do both, and I'm happy to do either. So there are the introductions and my introductions. A couple of other things that I want to show you at this point. Let's go into the content. Now, like I said, you're not going to be able to see all of this. So these things right here, you will not see at first. And that's because there are a couple of things that you need to do before you get to see that. In the quizzes, you'll see there's a scavenger hunt exercise, an acknowledgement activity, and the lockdown browser test. Those three things need to be done before you get to see other things in the content. Now, everything you need to do the scavenger hunt is available to you in the course documents. So we have all of this wonderful stuff that is present here. So you'll see the syllabus, the schedule, the syllabus addendum, that's mine, my course policies, a notebook format. Now, understand, for 110, you are not required to keep a notebook, but this is how you would keep one. And if you're going to be doing 111, you'll need to keep a lab notebook. So that will be required when you get to 111. So it might be useful to look at how that's going to be kept. Not everybody keeps theirs the same way, but these are things that I have been taught both, in school and in industry to do. So there's a sample of a lab notebook here. You'll see that there's the table of contents. Then we have experiment 1, the name, the procedure that we use, the objective, the materials, anything. And I have a picture here of the triple beam balance that was used in the lab. Notice that I've signed across that picture. The reason for that is if that picture gets removed, it's then obvious that something was taken out. Okay, so that's why that's there. You'll see that all of the equipment that I used was here. The procedure is listed. There's data with blanks so that I can write down that data as I go through things. So this is something that you can do for the virtual labs. I encourage you to do this for the virtual labs, and not necessarily in this format, but I encourage you to take notes while you do those virtual labs. Those virtual labs will be something that you are quizzed on. Okay, the quizzes that we're looking at are post-lab quizzes. They're in our homework program, which is called Alex. I'll set up a link to Alex through the shell, and I'll show you that in just a minute. But if you come in here and you go to your assignments, you'll see that there are post-labs. Those are quizzes, okay? Now, those quizzes are open note, completely open note, and you have time to work on them. You also get, for each one of them, 2 opportunities to work on it. And if you have to do it again, then you only have to see the questions that you missed the second time. You are more than welcome to use any notes, open resources, completely open on doing those post labs. And if you have any problems with it, talk to me about it, because I am more than happy to walk you through that. It's important that we do this. And one of the reasons that we do this is the labs that you're given are meant to show you what we've been talking about in the lecture. So to give you a different experience in working with that material. Those post labs are then meant to say, okay, based on what you've done, can you work with the data that you've collected? Can you work with that stuff? Because it's important that you be able to do so. It's important that you're able to do that on the exams. So having that connection through that is very, very useful. Okay, so that's why that's there. This is also where all of your homework is. The virtual labs are here in the post labs. So all of your homework's in here too. Yay. I told you that I would show you where you would get to that. And if we go into content, and I'll have all of our documents here, there's the lab manual, there's your exam handouts, and I need to mention this. The exam handouts, this document should change in the next couple days. But this set of documents, I absolutely expect that you're going to print this and use it on your exams. The best thing that you can do is to print it and use it to work on the worksheets that you're given to work with in the course. Because if you know where everything is in that handout, it makes it a lot easier to find it on a test. Okay, so when you're under a time constraint, then you know where things are. And we'll refer to this a lot in the lectures. There's a lab manual that's here. This lab manual is the one that we used to use for this course. You'll see that there are labs that are very similar to the virtual labs that you've been given. So the virtual labs are based on the labs that we used to do. There is some information in here that you will need to look at. So one of the discussions that we're going to have talks about common laboratory equipment, and that you could see here in the lab manual. There's also a list of technology requirements, things that you need to be able to do. So not only in terms of the actual equipment, but also your computer skills and your calculator. You need to have a calculator that is capable of doing scientific notation and scientific logs, anti-logs, that kind of stuff. So that's really important. Most TI calculators will do all of that stuff. There's also a list of student resources that are available here, because you may not know all of the resources that are available to you at TTC. These are available to any student. So there are links there so that you can go and look at what they have, any of that stuff that is available. Okay. We also have tutor.com, and that is listed here. It's also listed on the main page. So if you scroll all the way down, you'll see the user links, and then tutor.com here at the bottom. Now these user links are useful things. So I've gone out in the wild and looked on YouTube for things that are good explanations of things that are not mine. So if you don't understand what I'm talking about, here's another perspective. Okay, so all of this stuff is available to you as an additional way to look at all of these materials. It's probably best that you look at the ones that are listed here first, and then go find other ones if you want to or need to. Okay, so that's one of those things there. Going back to our content, sorry, I keep distracting myself. I love it when I do this. You'll see that there's this thing for ALEX, and right here there's an ALEX version 1.3. This is where you'll get to set up your link between D2L and ALEX. Okay, and that link needs to be set up so that the grades transfer over appropriately. You'll be taken into the shell for your course. This is not what it looks like for you. Actually, I can show you what it would look like for you. So you'll come in here and they'll ask you, they'll show you some tooltips. You should go through this. The tutorial, that's useful as well. But a couple of things that you'll need to be able to look at. The textbook is available here. So there is a textbook. You are expected to use it and look at it. Okay. And why can't I see the assignment list? Should be able to get to assignments from here. Oh, it's because I haven't done the tools, because I haven't done the tutorial yet for the tools. But there is, once you've done that tutorial, you'll see the assignments here as well. And then you can get into that assignment list to see what's due and when. Okay, so that's important for you to know. All the due dates for Alex are listed in Alex. Okay, but they're also listed in the not that lecture schedule, or which I keep calling it a lecture schedule, but it's just the schedule because it's lecture and lab. So you'll see for each topic that we're talking about. So here on this date, 1st of June, for full summer course, we're going to be doing lecture 2, which is atoms and atomic structure. And that's going to be the homework, atomic structure, which is labeled 2, which is in Alex. Now, your recommended due date, the date that I recommend that you have this done by, is the 3rd of June. Okay, so the next 2 days later is typically what it is. And then you'll see that there's another date below that. That's the date that is actually due. Now, you can turn it in after that, but there's a 40% penalty if you turn it in late. So be aware that is something that is present. Alex is kind of a pain in terms of how it accepts answers and what it will take. If you don't do what it's expecting, it's not going to give you full credit. So I do go back at some points and look and see if people deserve more points. But if you run into something where you think that you deserve points, then let me know. Screenshot, send it to me, let me know. So that's there. Now, the other thing you'll see in this is when we're talking about atoms and atomic structure, you'll see that it says chapters/sections. I'll actually blow this up a little bit. And here it's 2/1 through 3, and then should be 3-1, and then 7/7 through 9. Okay, so those are the textbook chapters, and then the sections within the textbook that we're talking about that material from. Now, I have made a list, one of the checklists, that says, hey, here are the things that I would recommend that you do. So, realistically, in a college course, what we're expecting is that you're going to have read the textbook before you come to the lecture on that material. We expect that because we don't want you hearing about it for the first time in that lecture. You need to have some idea of what this stuff is. Now, it may not sit, you may not know all about it. It may not sit very well, and that's okay, because you're going to hear about it again. And that's to help reinforce that information, to clarify anything that you didn't understand, that kind of stuff. Now, I will, and my lectures are often fairly short. I'm going to try and spend more time covering these materials. After that lecture is over, there is an expectation that you're going to do some other things. So after that lecture is over, that's step 3, I want step 4. You will see that there are things in the content that you're supposed to be doing. Now, the expectation is that you'll listen to the lecture and then you'll do the in-class practice, right? That's how this is designed. So if you go into the exam stuff, which you won't be able to see yet, again, until you've done the acknowledgement activity, you won't be able to see this. But when you come in here, you'll see that this is the in-class practice. These are the practice problems. This is the practice problems. And then this are the chemistry lever texts. And the PowerPoints will be in here as well. They will be first. And then the lecture recordings will be right underneath that. Again, I haven't loaded all of that yet. Okay. So, but there will be a PowerPoint lecture that you can look through before you go to the lecture and while you're in the lecture. Okay. And then you can watch the lecture. And then we have class practice. So these worksheets are designed so that you can do them to start building those blocks that we need to be able to do these things that we're asking you to do. These blocks are taken from high school chemistry or chemistry 100 here, so lower level chemistry. So it's less detailed than what we're going to need to do in the long run. Once you've done that, you'll see that there is a list of questions that I would ask about these particular materials. Okay? There's the questions, then there are the questions with answers. Now, I cannot emphasize this enough. While there are answers provided to you, it is absolutely recommended that you look at this without those answers, because you need to know if you know how to find those things, how to answer those things, how to do those things. And you won't necessarily know if you know how to do it if you're looking at my answers, because you may say, oh, well, that makes sense. And then when you go to do that problem on your own, you don't know how to approach it. Okay, I've seen that with people in the past. It doesn't always happen, but it often does. Okay, so these are some of the ways that I would ask these questions. And recommend that you go and do the ALEX stuff, okay? Because that is another level of difficulty. So we build in difficulty as we go through these things. Now, once we get to the end of a unit, so each one of these is for an exam, you'll see that there's a practice sheet, a whole bunch of questions about what you might see for this particular test. So questions that you can expect. I will tell you, point blank, quite often, questions on the test come directly from this document. Okay? Most of the time, they're not changed at all. Sometimes I will change some of the numbers that are in them just to make sure that you're paying attention to what you're supposed to be doing and not using something that you've already worked on, which is not supposed to happen. So there is that. Notice, again, that there is a one without the answers and one with the answers, okay? And I, again, recommend to you that you do this with your exam handouts. Nothing else. Exam handouts, calculate. See if you can do them. And if you can't do them, then you need to start asking questions. And that may be, it may be that you don't understand what the question's asking. It may be you need clarification over something that's in it. It may be that you don't understand that concept well enough to be able to answer that question, like you're missing pieces of that information. Those are questions that you should be bringing to me, hopefully before the test. Now, if you get through the first test and you look at your test after the fact and the feedback is not great, then you will probably want to review that to see what you missed and see if you can figure out why. You will get feedback for your tests, so all your tests are going to be in D12. You will get feedback for those. It will show you the question, the answer, and your answer. Okay, so, and that's done so that you can review. Again, if you miss anything, it is my expectation that you will come and talk to me about that. All right, so that's kind of where we are with that. So that's what you'll see. There is one of these for each exam with the review sheets in them. Okay, you will find, and when we get to it, and let me come down here, you'll see that there are folders within here: mass and volume experiment information, density experiment information. Okay? And then there's this additional resources, and these are a couple of things that you might want to review. I'm going to move them out of that folder, but these are a couple of things that you might want to review about the topics that we've talked about for this particular topic. Now, reading volumes on glassware, so some things that we would mention if we were in a physical class: mass and volume determination. This is what we would have done in the physical class. Okay, so this is how we would do that. This is the data sheet that would have been used if you were in the physical lab. And this is what you would fill out when doing a report for the physical lab. Now, none of those are required. Absolutely none of those are required. The expectation is that you should be able to do those things based on the virtual lab that you do. Okay, so understand that that's what we're talking about for that. There will also be a recorded lecture that goes into this to talk about that lab and the post lab, the stuff that you might see there. So there will be a recorded lecture that goes in there, and there will be a guide to where is that information for each lab. So where would I find it, just in case I can't find it? There's that as well. Discussions. Let's talk about the discussions. So this term, we're doing something new. We're not having a lab final, which is something we've done in the past. We are actually having some discussions that you guys are going to be working on. Now, you can separate it into groups. Each group is 4 people, hopefully. For most classes, we have that. The first set is the group-specific discussions, and so you'll see that each group is asked the same question. They're presented with, how is lab equipment used? Okay. And so you can open this up and say, all right, what is this about? You're given a scenario. Okay, here's what we're talking about. Here are some of the goals of what we're talking about. Here are some materials that are available to you. And then instructions for what you're supposed to be doing. Okay. Basically, what happens with these discussions is that you are supposed to come up with a proposal for how to investigate this question that you're supposed to be investigating. Okay, how would you do that? How would you use the lab equipment that is available? What data would you collect? What would that data tell you? Once you've made those proposals, so let me back up just a little bit. So within this group 1, each person needs to post twice. First one is about, how do you think that this should be approached for the proposal? You guys should then discuss how you're going to propose that. Okay. And then when you come into the proposal discussions, your group, one post for your group needs to get put in here to tell me, what is your proposal? Once you've made a proposal, I will actually then physically go into the lab and do what you proposed. And I will make some videos sometimes, I will collect some data for you, and then I will show you, I will provide that back to you as a response to your proposal. Okay, that should be done within 2 days of when I get the proposal. Okay. Then second thing that you need to do in the group discussions is, once you've got that data, you need to come back in here and say, okay, I think that data tells me this, or I think we need to do this with that data. How are you going to handle that data? What have you concluded from that data? What is it that data has provided to you? Did your proposal work? How do you know it worked? If it didn't work, why do you think it didn't work? And what I'm going to tell you is that it doesn't matter what you say. It doesn't. You can say anything you want. What we're looking for here is to build the thought processes that need to be done using the scientific method. And one of the things that you'll find in this content section is that there is a discussion about the scientific method. Okay, that's right here. So there is a discussion about the scientific method and what that means and what we're trying to do. You need to develop an idea based on what you know for how to do this, then collect some data, which of course you can't collect, I'm going to collect for you, and then analyze that data, make some conclusions from it. Okay, in each of the discussions in the posts that have been given for them, you will see that I have asked for some very specific information in the report. Okay. And it also talks about the expectations of, here's what you need to do, here's how you need to post, that kind of stuff. All right. So that's what we have there. Now, once you've done your second group discussion, we need a comment to your proposal that states what you've concluded. Okay. And then once you've done that, you are responsible for responding to at least one other post in the proposal thread with a comment on something you liked or that you hadn't thought of. So if they did something that you hadn't thought about, you can say, hey, we didn't talk about that. Why did you? What did you? What inspired, just, I hadn't thought about that. Thanks for pointing that out to me, because now I know something else that maybe I should have been thinking about. And there will be comments from me about what's been proposed, and you may get additional questions that say, is that really going to work for you? Or is that the best way to do that? Or is that going to give you the information? I don't make direct comments. I generally say, how is that going to work? That kind of stuff. It's called the Socratic method. So I'm making you answer to me and guiding where your thoughts are going. So there's one comment like that. And then you either need to point out either a question for how the group would handle the data collected, or a did you consider kind of question. So you can look at their proposal and say, all right, here's something that we thought about. Did you consider this? So if it appears that they have not considered everything, point out something that you think might be relevant to this. And again, that may be true, may not be true. It actually doesn't matter. Okay. What's important is that we're talking about things and we're thinking about those things and we're getting that discussed. All right. It's never bad to be wrong. And I hate to say it, but usually when we're wrong, we learn a lot more. It tells us a lot more about what is actually going on than when we do things right. Okay. So those are the kinds of things that we're looking at with those discussions. So there are a number of different posts that have to be done. Make sure that you're aware of all of them. Okay. Each of those is graded. So it's 100 points per posting set. So, and there are individual points for each required post. So 2 to the group discussions and 1 to the proposals. So there will be points associated with all of those. You can turn in these submissions late. Okay, it can happen. It's not good for your group if you do it late. And if you're in a group where somebody hasn't done it, then make note that not everyone participated. So tell me, these people, my investigative team was, and these are the people that contributed to that. Okay, so that way it's reflected that we know it wasn't everybody who was involved in that discussion. Late submissions are things that can be done, but it will result in a 50% penalty to your grade. Okay, so that's all there is about that. Your discussions end up being 20% of your lab grade. So that ends up being, I think 5% of your overall grade. Five 5% of the total. So, and there's your intro, discussion 1, discussion 2, discussion 3. And those are due roughly the same time as the 3 exams. Okay. So that's what we're talking about for those. All right. There will be quizzes that are posted for each lecture. So if it's a lecture 2 quiz, that's meant to be taken after you've done lecture 1, but before you do lecture 2. The questions that are being asked are questions about, they're questions about what are the topics for lecture 2, and then review questions from the first lecture. I do not expect that you're going to get everything right. I don't. And in fact, these will be given as a pass-fail. The only reason that they're quote unquote graded is so that I can see if you're struggling with something. Okay? So I need to see your thought process as much as possible in the answers that you provide. Okay, there is an assignment Dropbox for Quiz Scratch. So if you want to provide me Quiz Scratch and say, I didn't understand this part, or I need help with, or just anything like that, you can put that in the Quiz Scratch and I will take a look at it and get back to you as soon as I can. All right. You can also email me with things like that. So, my expectation is that I will be in each D2L shell every day Monday through Friday, every day, for some period of time. That will be used to look at those quizzes. It will be used to look at your discussions. It will be used to review the ALEKs that you've done, that kind of stuff. And of course, dealing with any of the email communications that you've sent to me. Now, I do have, and actually I don't want to be in content, I want to be here. I do have office hours. And my office hours are held either in person or remote. Doesn't matter. If you only want to come remote, that's fine. You don't have to come in. I have office hours on Monday from 11 to 12, Tuesday from 10:30 to 11:30, and from 1 to 3. I get a lunch break. Wednesday from 11 to 12, remote, WebEx only. So I won't be on campus that day. And Thursday from 12 to 2. Notice I have no office hours on Friday. I work a short day on Friday, so I can schedule appointments with people. If you need to meet with me on a Friday, I will do Saturday, Sunday evenings, early mornings, whatever. That's generally what we're talking about. My typical hours on campus, typical hours that I'm working are 8 to 3. I leave early, but again, I do a lot of work from home as well, so you can usually send me stuff and I'll find it. I cannot guarantee that I will be checking email outside of those hours, but I will get to it as soon as I can. Okay. I think that's everything that if you want to know where my office hours will be, you can click this link right here and it'll take you into the WebEx for my office hours. And if it's an office hour time, it's usually open. If it's not an office hour time and you click into it, then I will get a notification that you're in it. But depending on when I get an email sent to me. But if I'm trying to do something, that requires concentration, I don't always have my email open, so I may not see it. Okay, so there is that. I think that's everything that I needed to point out. I don't think there's anything else. So you may notice when you're in the discussions that your group has a name. All groups are named after scientists, and then there's information about who that scientist was and why they're important. There's a link to their bio on Wikipedia, as well as any significant things that they've done. So a wiki article about that. Now, Wikipedia is not the best source. It isn't. There are errors that are on it. But I will tell you right now, I review those pages, and I am a Wikipedia reviewer. So I can go in and correct things that I find that are wrong. So anything that I've referenced to you, unless it's been changed, in the last couple days, is probably okay. All right. So that, just understand that there are some of us who are that neurotic. We do work to make sure that there is useful and verifiable information in Wikipedia, but it's not always great. So anyway, that's my little thing about Wikipedia. So I think that's everything I was going to talk about in the introduction. Hopefully I haven't bored you to death, and this took a lot longer than I expected to, but I hope that it's a great semester. I am really hoping that I will get to know and work with each and every one of you. So I will talk to you guys later. Thanks.